All right, so we're diving into this research paper from back in 2014 from Amazon Web Services.
Yeah.
Use of formal methods at Amazon Web Services. You know, you probably wrestled with the complexities of distributed systems before.
Right.
And this paper, it tackles exactly that, but on Amazon's massive scale.
Yeah, it's fascinating how they highlight the limitations of like traditional testing. You know, when you're dealing with systems like S3, their simple storage service. By 2013, S3 was already storing like trillions of objects.
Oh, wow.
And handling millions of requests per second.
It's mind-boggling to think about that scale.
Yeah.
And the paper, you know, talks about the intricate algorithms behind these services.
Right.
Like replication, consistency, concurrency control, all potential breeding grounds for these subtle, hard-to-catch bugs.
Yeah. And they even quote C. Michael Holloway from NASA, who said, accidents are almost always the result of incorrect estimates of a likelihood of one or more things. Kind of a stark reminder that our intuition can fail us.
Yeah.
Particularly when we're dealing with, you know, such complex systems.
So testing alone isn't enough, especially when it comes to design flaws.
Right.
That's where formal methods come in, though I'm sure you've heard the usual arguments against them.
Oh, yeah.
Too time-consuming, only for small or safety-critical systems.
Yeah. The paper addresses those misconceptions head-on.
Yeah.
They reframe formal methods as exhaustively testable pseudocode, you know, focusing on practicality and return on investment. Their chosen tools are TLA Plus and PlusCal.
Could you elaborate on those a bit?
Sure. So TLA Plus is the formal specification language. It's grounded in, you know, set theory and predicates, concepts, you know, I'm sure you're already familiar with.
Yeah.
And PlusCal provides a more programmer-friendly layer on top of TLA, plus making it even more approachable, you know, for engineers.
So it's about bridging the gap between, you know, these rigorous mathematical concepts and practical software development.
Exactly. And the paper's refreshingly honest about Amazon's, you know, initial skepticism.
Oh, really?
They had the same doubts
Okay.
about formal methods being too cumbersome for their scale and speed. But their experience is proved those assumptions wrong.
That's quite a testament to the power of these methods. But what about the learning curve?
So one of the most compelling points they make is that the learning curve is surprisingly short. They claim that, you know, engineers, even those without prior experience, can pick up TLA Plus and get useful results in just a few weeks.
A few weeks to potentially prevent major bugs. That's a pretty good trade-off.
Yeah.
Do they share any specific examples of how this played out in practice?
Absolutely. They delve into DynamoDB, which is, you know, their highly consistent replicated data store.
Right.
Ensuring strong consistency in a distributed database like that, it's notoriously challenging.
Yeah.
You know, with data replicated across multiple servers, any inconsistency can lead to data loss or corruption.
Yeah.
And that's where TLA Plus came to the rescue.
Okay.
TLA Plus uncovered a subtle data loss bug that had slipped past all their other verification methods, and the model checker was actually able to generate a 35-step error trace to pinpoint the bug.
35 steps.
Yes, 35 specific events that had to occur in a very precise sequence for that bug to manifest.
Wow.
It's highly unlikely that, you know, traditional testing would caught that.
Yeah. That's a powerful example of how formal methods can kind of find those needle in a haystack bugs. Did they have similar success with other services?
Yeah. They also talk about how TLA Plus helped them verify a very complex network algorithm for S3.
Okay.
And they were initially planning a brute force testing approach,
Oh, wow.
but they quickly realized that that was going to be incredibly time consuming.
So TLA Plus offered a much more efficient and effective solution.
Exactly. The formal specification not only helped uncover bugs, but also verify the fixes. So it really streamlined that whole process.
So it's clear that TLA Plus had a significant impact on their development process. But beyond just like catching bugs, did it change how their engineers thought about like designing systems?
Yeah, so the paper highlights a shift in focus from what might go wrong to what needs to go right.
Okay.
Instead of trying to anticipate every possible failure scenario, they started by really clearly defining the desired behavior of this system.
Oh, interesting.
The correctness properties.
Okay.
So, you know, they specify safety properties, what the system is allowed to do. and liveness properties,
Right.
what the system must eventually do. And this forces them to really explicitly state all the assumptions that their system relies on.
So it's not just about preventing failures,
Yeah.
but also about ensuring that the system behaves as intended under normal conditions.
Exactly. And by modeling the operating environment and the effects of, different events like failures, restarts, network issues, they gain a more comprehensive understanding of, how the system works.
Right. As a whole.
As a whole.
Yeah.
It seems like this what needs to go right mindset leads to a more robust and resilient design.
But what about the long-term benefits? Did TLA Plus continue to be useful even after a system was live?
That's where it gets really interesting. The paper highlights how these formal specifications, especially those written in TLA Plus, they become valuable assets that continue to pay dividends long after the system is deployed.
Oh, I'm intrigued. Tell me more about these long-term benefits.
So think of it as a what-if tool. You can use the model to explore the consequences of design changes, ensuring that new features or optimizations don't introduce subtle bugs.
So it's like having a crystal ball for your system.
Yeah, exactly.
Well, that sounds incredibly valuable, especially as systems evolve over time.
Right.
Are there any other long-term benefits?
Yeah. So because the specification is so precise and unambiguous, it acts as this living documentation,
Okay.
which is invaluable for onboarding new team members or
Yeah.
even for the original developers who, might need to revisit the system after a long time. It's really easy to forget those details when you're dealing with, systems of this complexity.
And having that clear documentation can save a lot of time and effort down the road.
Mm-hmm.
Did they mention any other long-term advantages?
Yeah, so the paper emphasizes that having this level of confidence in the design allows engineers to make more aggressive performance optimizations
Okay.
without worrying about, breaking the system's core logic.
So it's a win-win situation.
Exactly.
You get a faster, more efficient system, but you don't compromise correctness.
Right.
That's a compelling argument for using formal methods.
Yeah.
Did they mention any unexpected applications of TLA Plus?
Surprisingly, yes. They used TLA Plus for data modeling.
Oh, wow.
Specifically designing database schemas.
Interesting.
It turns out that data models can be seen as just another level of abstraction in the system.
Okay.
And using TLA Plus in, they were able to define rich semantic invariance over the data, going beyond standard constraints.
So they're not just verifying the behavior of the system,
Right.
but also ensuring the integrity of the data itself. That's fascinating. It's amazing how versatile this approach seems to be. But I imagine there are limitations to what TLA Plus can do.
Of course.
What did they say about that?
They acknowledge that, TLA Plus isn't a silver bullet.
Right.
One limitation they mentioned is the challenge of modeling and predicting sustained emergent performance degradation,
Okay.
especially those caused by feedback loops in the system.
So while TLA Plus can catch, many types of bugs, it's not a magic solution for all performance problems.
Right. Another limitation is that, at least at the time of the paper, TLA Plus couldn't be used to directly verify code correctness or generate code from specifications at the scale that Amazon operates.
Right. That makes sense. So how did they bridge that gap between the verified design and the actual code?
That's a great question. It's something engineers ask a lot.
Yeah.
And the paper acknowledges that there's no guarantee that the code perfectly reflects the spec. However, they argue that formal methods still provide multiple layers of protection.
I'm curious to hear more about these layers of protection. What did they highlight?
So, firstly, getting the design right is a crucial first step.
Yeah.
If the design is flawed, the code is almost certainly flawed as well.
Right.
Formal methods help eliminate that major source of errors
Right.
by ensuring that the design is solid from the start.
It's about building on a strong foundation.
Exactly. Secondly, the deeper understanding gained through the formal specification process leads to better coding practices.
Okay.
Engineers are more aware of, the nuances and the potential pitfalls,
Right.
which translates to higher quality code.
So it's about improving the entire development process, not just, a single stage.
Yeah. And thirdly, formal specifications can actually help you write stronger assertions in your code.
Yep.
Assertions are those, self-checks that you put into your code
Right.
to make it more robust and able to, detect inconsistencies during runtime.
Right. Like built-in alarms that go off if something goes awry.
Exactly. And while they couldn't directly verify code against the specifications at the time, they mentioned some research that was exploring the use of TLA plus to generate targeted test cases,
Okay.
which could further bridge that gap.
So it's a constantly evolving field with lots of promising avenues for exploration.
Indeed.
Well, this has been an incredibly insightful look into Amazon's journey with formal methods. It's fascinating how they took these theoretical concepts and applied them to solve real-world challenges at such a massive scale. Before we move on, I'd love to hear how this story unfolded, within Amazon. It wasn't an overnight adoption, was it?
You're right. The paper tells quite an interesting story about how formal methods gradually gained traction, within Amazon.
Okay.
Starting with a single engineer's quest for better system design.
It sounds like a classic tale of innovation starting from the ground up. Could you walk us through that journey?
Of course. So it all began with Chris Newcombe, one of the authors of the paper, who was driven by his dissatisfaction with the quality of certain distributed systems.
Okay.
Even those that, were considered successful.
It's that desire to build truly reliable systems that often drives innovation.
Absolutely. Interestingly, Newcombe didn't initially consider formal methods. The prevailing view at the time was that they were, too cumbersome and impractical for real-world systems.
Yeah, that perception definitely existed and to some extent still lingers in some circles today.
Yeah.
So what changed his mind?
So he stumbled upon a paper by Pamela Zave, who had successfully used a formal specification language called Alloy to find serious bugs in a well-known distributed system called Cord.
That sounds like a pivotal moment.
Yeah.
So that sparked his interest in formal methods.
Exactly. Intrigued by the possibilities, Newcombe started, experimenting with Alloy himself, writing specifications, model checking a concurrent algorithm. And while they found Alloy promising, they also discovered some limitations in its expressiveness, particularly when dealing with complex data structures.
So the search for a better tool continued.
Yeah. So Newcombe continued searching for a language with, similar conceptual underpinnings to Alloy, but with more expressive power.
Okay.
And that's when he encountered TLA plus Alloy.
Ah, the turning point.
Yes.
What was it about TLA plus that caught their attention?
So the paper mentions that finding a TLA plus specification in the appendix of a paper on the Paxos consensus algorithm was kind of a key moment.
Okay.
Paxos is, a cornerstone of distributed systems.
Yeah.
So the fact that its designer, Leslie Lamport, had used TLA plus really gave them confidence in its capabilities.
So the credibility of the creator played a role.
Definitely. And they were further encouraged by learning that TLA Plus had been used to verify complex cache coherency protocols for the Alpha series of multi-core CPUs.
Right.
So they had proof that TLA Plus could handle, real-world concurrency and fault tolerance.
They had found their tool.
Yeah.
But now the challenge was to convince others within Amazon.
Exactly. And as the paper points out, engineers are often skeptical of anything that sounds overly academic or impractical.
Yeah.
So Newcombe had to find a way to present TLA Plus in a way that resonated with their, engineering mindsets.
That must have been tricky. How did he go about doing that?
So instead of talking about, formal methods, verification, or proofs, he really focused on the practical benefits.
Okay.
He framed TLA Plus as a powerful tool for debugging designs. He even called it, exhaustively testable pseudocode, emphasizing its practicality and its connection to familiar concepts.
That's a clever way to make it more approachable.
Yeah, and it worked.
Okay.
After seeing Newcombe's presentation, a team working on S3 actually reached out to him for help verifying a new fault-tolerant network algorithm.
Ah, so they had their first like real-world test case within Amazon.
Exactly. This team was initially considering writing like a Java program to brute force explore possible executions of their algorithm.
Wow.
But with the help of TLA plus Day, they were able to avoid that massive effort.
So not only did TLA plus Day, find bugs, but it also saved them, time and resources.
Precisely. And this success story, it had a ripple effect.
Okay.
Other teams within S3 started adopting TLA plus Ren, and word began to spread
Throughout the company.
A
classic example of how, a successful pilot project can lead to wider adoption.
Indeed. The paper details several other, successful implementations, each one highlighting the value that TLA Plus brought to the table.
It's remarkable how quickly a cultural shift can occur when people see tangible benefits.
Yeah, and the support from management is crucial for that shift to happen.
Right.
The paper mentions that that executive management at Amazon, they became proactive.
Oh, wow.
In encouraging teams to use TLA++. They even allocated, engineering time for it.
That's a strong indication of how much they valued this approach.
Absolutely. It shows a real commitment to building reliable systems and a recognition that formal methods, even those that might seem, unconventional, can play a key role in achieving that goal.
So what started as one engineer's quest for better system design eventually transformed how Amazon approached software development at scale.
Yeah. And the paper concludes with a note of caution.
Okay.
Reminding us that formal methods deal with models, not the systems themselves. While incredibly useful, they're not a substitute for careful engineering and a deep understanding of the real-world complexities.
Right. It's about finding the right balance between, the rigor of formal methods and the practical realities of building and deploying these complex systems.
Exactly. It's a journey of continuous improvement.
Yeah.
And Amazon's story really demonstrates how embracing, these unconventional tools and mindsets can lead to remarkable outcomes.
Well, this has been an incredible deep dive into Amazon's journey with formal methods.
Yeah.
It's a fascinating case study of how theoretical concepts can be applied to solve, real-world challenges at a massive scale. We've covered a lot of ground in this first part, and in the next part we'll explore the nuances of TLA plus when and how Amazon tailored its use to fit their specific needs. Stay tuned, because there's a lot more to uncover in this story of innovation and engineering excellence.
Right. Welcome back to our deep dive into Amazon's use of formal methods. Before we moved on, we were discussing how Amazon's journey with formal methods began with one engineer's quest for better system design.
Right. We left off with Chris Newcomb's discovery of TLA Plus and how its use in designing the Paxos consensus algorithm really provided validation for its capabilities. So how did this one engineer manage to introduce this new approach to the rest of Amazon?
That's a great question, and the paper does a good job of highlighting the strategies that Newcombe employed to really advocate for this new way of thinking. He recognized the need to address engineer skepticism head-on, particularly the perception that formal methods are too academic or too impractical for large-scale systems.
So he had to find a way to make it relevant to their day-to-day work.
Exactly. Right. So instead of using, jargon-heavy terms like formal verification or proofs, he really focused on the practical benefits.
Okay.
He framed TLA Plus as a powerful tool for debugging designs.
That makes sense. Engineers are always looking for ways to catch bugs more effectively.
Precisely. And he emphasized that TLA Plus could handle the scale and complexity of Amazon systems, drawing on examples of its use in verifying complex cache coherency protocols for multi-core CPUs.
So he was able to demonstrate its real-world applicability.
Yes. And he also made sure to address the perceived, steep learning curve that's associated with formal methods. He pointed out that engineers could become proficient in TLA Plus within a few weeks, even without prior experience.
That's a compelling argument, especially for engineers who are always, pressed for time.
Yeah.
Did this approach resonate with the engineers at Amazon?
It did. And the paper highlights a key turning point. A team working on S3, they reached out to Newcombe for help verifying a new fault-tolerant network algorithm.
Yeah.
They were initially planning to use a brute force testing approach, which would have been incredibly time-consuming.
Right. So TLA Plus presented a more efficient solution.
Exactly. With the help of TLA Plus, they were able to verify the algorithm, catch bugs much faster than they could with traditional methods.
It sounds like this success story played a crucial role in demonstrating the value of TLA Plus to other teams within Amazon.
It did. This pilot project, it really served as a proof of concept, showing that TLA Plus could deliver, real results in a practical setting.
That's a great example of how a successful implementation can pave the way for wider adoption.
Yeah.
Did other teams follow suit.
Yes. And the paper describes how this initial success really created this ripple effect
Okay.
within Amazon. Other teams within S3 began using TLA Plus and word spread,
Throughout the company.
throughout the company.
It's fascinating how these things often start small and then gradually, gain momentum.
Absolutely. And the support from management
Right.
really played a significant role in accelerating this adoption.
Okay.
The paper mentions that executives at Amazon, they recognized the value of TLA Plus, and they actively encourage teams to use it. They even allocated, engineering time for formal methods.
That's a strong indication of how seriously they took this new approach.
It is. It shows a real commitment to building, reliable systems and a willingness to invest in tools and techniques that support that goal.
So what started as one engineer's, initiative eventually became a company-wide practice.
Exactly. And the paper makes it clear that this wasn't just, a top-down mandate.
Right.
Engineers embraced TLA Plus because they saw the value in their day-to-day work.
It's a great example of how a cultural shift can occur when a new approach, demonstrably improves the way that people work.
Now that we've discussed how TLA Plus was introduced and adopted at Amazon, let's delve a bit deeper into the technical details of this approach.
Yeah.
You asked earlier what a TLA Plus specification actually looks like.
Yes, I'm curious to understand how it works in practice.
Imagine you're defining the rules of a game.
Okay.
You specify the players, their possible actions, and how those actions affect the state of the game.
Right.
TLA Plus is similar in that you use it to describe the components of your system, the events that can occur, and how those events change the system's state.
So it's like creating a blueprint for how the system should behave.
Precisely. And TLA Plus achieves this rigor by employing mathematical concepts that are familiar to most engineers.
Right.
Set theory, logic, and predicates.
Right.
These serve as the foundational building blocks of TLA Plus.
So it's rigorous without being overly abstract or esoteric.
Right. And as we discussed earlier, PlusCal provides a more programmer-friendly way to write those specifications.
Okay.
It feels more like writing pseudocode while retaining the rigor of formal methods.
It sounds like PlusCal helps to bridge the gap between formal methods and traditional software development.
Exactly. Now, once you've written your TLA Plus specification, you can use a tool called the TLC model checker to verify its correctness.
Okay.
TLC systematically explores all possible executions of the system, based on the rules you've defined.
So it's like simulating the system's behavior in a controlled environment.
Yeah.
To see if any violations of the specified rules occur.
Yes, and if TLC finds a violation of your correctness properties, it generates a detailed trace.
Okay.
That shows you exactly how that violation occurred.
Right.
And this trace is incredibly helpful for debugging the design and understanding why the system didn't behave as expected.
It's like having a detective.
Yeah.
That can pinpoint the exact sequence of events leading to a crime.
A very apt analogy. The paper emphasizes the importance of modeling the operating environment in these TLA Plus specifications.
Why is that so crucial?
Because real-world systems don't exist in isolation.
Right.
They're subject to external factors like network failures, disk crashes, even human errors.
Right.
And by explicitly modeling these factors in TLA Plus, you can ensure that your design is robust.
Right.
And can handle those unexpected events gracefully.
It's like proactively stress testing the design.
Precisely.
Before you even write a single line of code.
And as we touched upon earlier, the paper highlights this crucial mindset shift that TLA Plus encourages, focusing on what needs to go right rather than what might go wrong. I'm still
intrigued by this concept. Could you elaborate on how this shift in thinking really changes the design process?
Of course. So instead of trying to anticipate every possible failure scenario, which is practically impossible. You begin by really clearly defining the desired behavior of the system. You specify the safety properties, ensuring the system never enters an invalid state, and the liveness properties, guaranteeing that it eventually achieves its goals.
So it's about setting the boundaries first,
Mm-hmm.
defining like the rules of the game,
Yeah,
and then ensuring that the system always plays by those rules.
exactly. So by shifting the focus to what needs to go right, you're not just, preventing failures.
Yeah.
You're also ensuring that the system behaves as intended
Right.
under normal circumstances. And this approach leads to a more thorough and robust design that's better equipped to handle, both expected and unexpected events.
So far, we've discussed the general principles of TLA Plus and its application, in a practical setting. But Amazon systems are renowned for their scale
Mm-hmm.
and complexity.
Right.
How do they adapt TLA Plus to meet the specific demands of their environment?
Yeah. That's a great question. And the paper does provide insights into the adaptations that they made. One key adaptation is the use of abstraction.
Could you explain how abstraction plays a role in formal specification?
When you're dealing with systems as complex as Amazon's,
Right.
attempting to model every single detail would be overwhelming
Right.
and computationally infeasible.
Yeah.
Abstraction allows you to simplify the model
Right.
by focusing on the core logic and interactions
Right.
while omitting, less critical details.
So it's like creating a simplified representation of the system,
Yeah,
highlighting the essential aspects without getting bogged down in the minutia.
exactly. And TLA Plus supports hierarchical abstraction,
Yeah.
meaning that you can start with a high-level specification that captures the overall behavior of the system,
Right.
and then refine it, step by step,
Right.
adding more detail
Yeah.
as needed.
It's like building a pyramid layer by layer,
Yeah,
ensuring that each layer is stable before adding the next.
a perfect analogy.
Yeah.
And this hierarchical structure not only makes the specification more manageable,
Right.
but it also simplifies the verification process.
Right.
You can verify each level of abstraction against the one above it,
Right.
ensuring that the refinements don't introduce any inconsistencies.
It's a systematic approach to managing complexity.
Another adaptation that they highlight is the exploitation of symmetry.
Symmetry in software systems.
Yeah.
Could you elaborate on that?
So many distributed systems exhibit inherent symmetries.
Okay.
Or for example, in a system with multiple replicated servers,
Right.
each server essentially performs the same function.
Right.
TLA Plus allows you to leverage these symmetries during the verification process,
Okay.
significantly reducing the number of states that the model checker needs to explore.
So it's about recognizing, patterns in the system to streamline the verification process.
Precisely. By exploiting symmetry, you can verify the correctness of the system more efficiently,
Right.
making it feasible for larger and more complex systems.
It sounds like a clever way to optimize the verification process.
Yeah.
Without sacrificing rigor.
Exactly. And finally, the paper emphasizes the importance of choosing the right level of detail when writing TLA Plus specifications.
That sounds like a delicate balancing act.
It is a balancing act. You need to include enough detail to capture the essential behavior
Right.
of the system accurately.
Yeah.
But you also want to avoid making the specification so complex
Right.
that it becomes difficult to manage
Right.
and understand.
So it's about finding that sweet spot where the specification is both comprehensive and comprehensible.
Yeah. Precisely. The paper suggests that this is more of an art
Right.
than a science.
Yeah.
It requires, experience and judgment to decide, which details to abstract away and which to model explicitly.
It sounds like a skill that develops over time as you gain, more experience with TLA Plus and the systems that you're working with.
Absolutely. And they also emphasize the importance of collaboration and feedback in this process. Having multiple people review and discuss the specifications really helps to ensure that they're accurate.
Right.
That they're clear and at the appropriate level of detail.
It's a reminder that even with powerful tools like TLA Plus software development is still a collaborative process.
Yes. And the paper highlights how this collaborative approach also helps to spread knowledge and expertise throughout the organization.
Right.
By working together on TLA Plus specifications, engineers can learn from each other and build a shared understanding of the system.
It sounds like TLA Plus not only, helps to improve the quality of the system, but it also fosters this culture of collaboration and learning
Indeed.
within the engineering team.
It's a great example of how technical tools
Right.
can have a positive impact on both the product and the people who build it.
This deep dive into Amazon's use of TLA Plus has been incredibly insightful.
Yeah.
We've explored the technical details, the adaptations they made, and the cultural impact that it had. But I'm curious to learn more about how they specifically, convinced engineers to embrace this new way of thinking.
Yeah.
In the final part of our deep dive, let's explore the human element behind this technical innovation, and uncover the strategies that they employed to overcome skepticism and foster enthusiasm for formal methods. Stay with us, because there's still much to uncover about this remarkable journey.
Welcome back to our deep dive into Amazon's use of formal methods. Before we moved on, we were discussing how Amazon adapted TLA Plus to meet the demands of their complex systems and the role of abstraction and symmetry in that process.
Right, and I'm still fascinated by how they managed to shift the engineering culture at Amazon to embrace these, seemingly academic and complex techniques. What strategies did they employ to win over the engineers, especially those who might have been initially skeptical?
The paper does a great job of highlighting the human element in this, technical transformation. And one key strategy was demonstrating the practical benefits of TLA Plus and addressing, common misconceptions head on.
So it was about meeting the engineers where they were and speaking their language.
Exactly. Instead of presenting, TLA Plus as this abstract mathematical tool, they framed it as a powerful way to debug designs, emphasizing its ability to catch subtle bugs that traditional testing would likely miss.
That makes sense. Engineers are always looking for tools and techniques that can help them build more reliable and robust systems.
Precisely. And they also tackled the misconception that formal methods are only suitable for small safety-critical systems. They showcased real-world examples of how TLA Plus was successfully used to verify complex systems at Amazon scale, demonstrating its applicability to the challenges they faced, daily.
So it was about proving the value of TLA Plus through concrete evidence and relatable examples.
Yes, and they also emphasized the surprisingly short learning curve. They demonstrated that engineers, even those without prior experience in formal methods, could become proficient in TLA Plus within a few weeks.
That's a compelling argument, especially for engineers who are always under pressure to deliver results quickly.
Did they find that engineers were receptive to this message?
They did. And a key factor in this receptivity was the emphasis on collaboration and knowledge sharing. They encouraged engineers to work together on TLA Plus specifications, share their experiences, and learn from each other.
So it wasn't just about introducing a new tool, but also about fostering a community around its use.
Exactly. This collaborative approach not only helped, spread expertise throughout the organization, but it also created a support system where engineers could learn from each other's successes and challenges. It sounds like they recognize that cultural change is often more effective when it's driven from the ground up through peer-to-peer learning and knowledge sharing.
Absolutely. And they also provided, more formal support through internal presentations and workshops to introduce TLA Plus to a wider audience and spark interest in its capabilities.
It's interesting how they combined both informal and formal approaches to knowledge dissemination.
And importantly, they had the backing of management. The paper mentions that executives at Amazon became proactive in encouraging teams to use TLA Plus. They even allocated, engineering time specifically for formal methods.
That's a powerful signal that this wasn't just a grassroots initiative. It had the support and buy-in of the leadership.
It does. It demonstrates that they recognize the value of formal methods and were willing to invest in them to improve the quality and reliability of their systems.
So it was a combination of bottom-up enthusiasm and top-down support that ultimately led to the successful adoption of TLA Plus at Amazon.
Precisely. The paper really beautifully illustrates how how a seemingly complex and academic concept can be successfully integrated into a fast-paced, results-oriented engineering environment when you address the human factors effectively.
This deep dive into Amazon's experience with formal methods has been incredibly illuminating. It's a testament to the power of innovation, collaboration, and a willingness to challenge conventional wisdom. We've explored the technical intricacies of TLA plus the practical adaptations they made and the cultural shift that made it all possible.
And what's particularly remarkable is that they achieved all of this while maintaining their focus on delivering value to their customers. They didn't let the pursuit of technical rigor overshadow the practical needs of their business.
It's a reminder that innovation thrives when it's grounded in real-world problems.
Yeah.
And focused on delivering tangible benefits.
Absolutely. Amazon's story serves as an inspiration for all of us to explore unconventional approaches and challenge the status quo in our pursuit of building, better systems.
As we wrap up this episode, I'm left with a sense of awe at what they achieved.
Yeah.
And a renewed appreciation for the power of human ingenuity and collaboration. It's a reminder that even in the face of immense complexity, we can find elegant and effective solutions when we dare to think differently and work together. So as you go about your own work, consider this. What seemingly unconventional tools or approaches could you embrace to achieve similar breakthroughs? Keep those neurons firing, because that's what the deep dive is all about.